Dear students, welcome to the Let's Solve Physics channel. Okay, so in this video we will be solving question number 5 from second chapter, okay, from Concepts of Physics book. So here let us see what information has been given in the problem. Okay, so problem says refer to figure 2e1, find a magnitude b, x and y components and c the angle with the x-axis of the resultant of OA, BC and D. So here three vectors are given, vector OA, vector D and vector B, okay, and their angle is also given and their magnitude is also given, and we need to find three parts, okay, magnitude. Second part is x and y component and C angle with the x-axis of the resultant. So here important thing to consider is we need to find the resultant of OA, BC and D, okay, and if we find that, we need to find the magnitude of that resultant vector, and after that its x and y component and angle it is making with x-axis, okay. So we can write x component of vector A as magnitude of vector A cos alpha because we need to get the angle with respect to x-axis, okay, and similarly we can write the y component A of y as magnitude of vector A cos of beta because we need to find the y component, so projection of this vector A along y-axis, so we need to get the y angle, beta angle, okay. Beta angle is angle between vector A and y-axis, okay. So let us use this formula to calculate the components of vectors in the given problem. Suppose R is our resultant vector, okay, which we need to find that, okay. So how can we do that? Resultant vector, okay. So we can write vector R as vector sum of vector OA plus vector DE plus vector BC. So OA, DE and BC vectors are given. X component of OA in I direction plus Y component of OA in J direction plus X component of D in I direction, okay, plus Y component of D in J direction. J means Y direction and I means X direction, okay. And similarly for BC vector, so we can write it as X component of BC in I direction plus Y component of BC in J direction, okay. So now what we are doing here, we are just rewriting the previous formula, okay, like this. So here we need to calculate the resultant vector R, which would be the vector sum of vector OA plus vector D plus vector BC. So these are the given vectors in the problem. We just need to rewrite in form of their x component and y component, which I am doing it here. So I am writing vector OA as x component of vector OA and plus y component of OA. So this term represents vector OA, right? OA, x component of OA plus x component of D plus x component of BC, x components of all vector together, okay. And now we can write the y component together. So here y component of OA plus y component of D plus y component of BC in J direction, correct? So here we are just rearranging the terms. Okay, concept is same, that the vectors along same axis can be added up together. Okay, so here we are taking all the vectors, all the components along x-axis together and all the components along y-axis together. So I represents the unit vector in x direction and j represents the unit vector in y direction. Okay, so now let us calculate the components along x direction and y components along y direction. Okay, for each vector. Okay, so how can we do that? Vector r can be written as magnitude of OA. Okay, so it is OA, OA, magnitude of OA. Okay, cos of 30 degree, because OA is making angle of 30 degree with x-axis, plus magnitude of D cos of 90 degree. D is making angle of 90 degree with x-axis, plus magnitude of BC cos 120 degree. Okay, in I direction, plus, so now here we have just written the x component of those vectors. Okay, and we are trying to find the x component. So in order to find the x component, we need the magnitude of that vector and the cos of the angle which is being made by that vector with x-axis. Okay, so first vector is making angle of 30 degree with x-axis, second vector is making angle of 90 degree with x-axis, and third vector is making angle of 120 degree with that, okay, x-axis. So that's why we are taking like this. Now let us add y component can as angle made by that vector with y-axis. So here first OA is making angle of 60 degree with y-axis, so we will be taking 60 degree plus BC and cos of 30 degree with y-axis, because it is making angle of 30 degree with y-axis, correct? And this all the sum would be in j direction or y direction. Okay, so now let us calculate the actual value. Cos 90 plus theta is equal to minus sin theta. So cos 120 as 90 plus 30, we can write it like this, cos 120. So how much it will become? It will become minus of sin 30, and we know that sin 30 is 1 upon 2, so it would be 1 upon 2 minus of 1 upon 2. So cos of 120 would be minus of 1 by 2. Okay, so now let us calculate the actual value. So magnitude of OA is 2 and value of cos 30 is under root 3 by 2. So this is first term, plus magnitude of DE is 1 and cos of 90 is 0. This is second term, plus magnitude of BC is 1.5. Cos of 120 is, we just calculated how much it is, minus 1 upon 2. So this component is in I direction. Okay, so we can cancel this 2 with this 2 and this second term would be 0. Okay, so now let us calculate the y component. Okay, into cos 60 1 upon 2. This is first term. Second term is D, magnitude of D is 1, and then cos 80 is minus 1. Value of cos 80 is minus 1. So this is our second term, plus third term, magnitude of BC is 1.5 and cos of 30 is under root 3 by 2. Correct? So we can simplify this vector R as 1.732 minus 1.5 by 2 in I direction, 1.3j. Okay, we get like this, just solving previous calculation. Okay, so and if we further solve it, we will be getting r as 0.982 I plus 1.3 j. So here we have easily calculated the resultant vector by adding the x component of individual vector together and by adding y component of individual vectors together. So we are getting resultant vector as r as 0.982 in I direction plus 1.3 in j direction. Okay, so this is our vector. Okay, now let us calculate the further values. So magnitude of resultant vector will be a square root of x component squared. So x component is 1.732. So a square of it plus y component square 1.32 squared. Okay, and if you solve this, so you will get value as 1.64 meter. Okay, so this would be magnitude of resultant vector. And what would be the x component? We have already calculated that. So if you go here in the resultant vector, this first component along I direction represents the x component and the component along j direction represents the y component. Okay, x component of resultant is 0.982 meter. Okay, y component of resultant vector as 1.3 meter. And how can we find the angle between x-axis and the resultant vector? Suppose this is x-axis and this is our resultant vector. Okay, so how can we find that? We need to calculate the theta, angle theta between resultant and x-axis. So we know the formula tan theta equal to y component of that vector upon x component. So by putting those value, we get we know that y component of that vector is 1.3 and x 1.3 and x component of that vector is 0.982, and if we divide these values, we will be getting 1.32. Okay, so theta is tan inverse of this value 1.32. correct? So now let us write what we have found. Magnitude of resultant as 1.64 meter, x component of resultant vector as 0.982 meter, y component of resultant vector as 1.3 meter, and angle theta equal to tan inverse 1.32. So these are the required results, okay, which we need to find out. Okay, so we have found out. Okay, so these are the answers. Thanks guys, thanks a lot for watching.